Hello everyone, I am doing another physics video. And I'm going to go over homework number 1 and homework number 2. And without further ado, let us begin. And problem number 1 says, an airline passenger carries a 215 Newton suitcase by the handle up a flight of stairs, 4.2 meters vertically and 4.6 meters horizontally. How much work does the person do? How much work does the person do if they go back down the stairs? This is actually a really simple problem because you only need to calculate the vertical force. And the 4.6 meters horizontally doesn't even matter. It's simply there just to mislead you because, again, work is force distance cosine theta, and that distance only matters if it's the same direction. So like if that person's going up a flight of stairs, they can only carry it. They're not like pushing the staircase. And so basically, in essence, we can just ignore this horizontal. It's like we don't even need this. And now with that explained, 4.2 meters times 215 newtons, because again, FD cosine theta, or FD, assuming there's no angle, is work. So put into your calculator 4.2 times 215 newtons. And I don't know if you can see it, but you should be getting 903 joules. And that's how much the person does when they go up the stairs. And now when they go down the stairs, it's the same thing except it's negative. So, I mean, like, let's just say even if the person wasn't carrying it, if it was just gravity doing it, that also counts as doing work. And it's negative because if you were to go down, you would be going down negative 4.2 meters. So if you go up, it's positive. If you go down, it's negative. So basically, they're doing the same amount of work, except that this is negative. So you also got to be careful of that. And these are the answers. Hopefully you can see that a bit more clear. And number 2 says, Lynn is pulling her cousins around in a red radial flare wagon. Lynn pulls the wagon with a force of 100 newtons at an angle of 50 degrees from the horizontal. How much work does Lynn do if she pulls the wagon for 15 meters? Again, we need to be careful at this point because we need to know which direction is going. In this case, Lynn is pulling her cousins, which means this is in the horizontal direction, the x direction. And we only care about the horizontal direction. The vertical direction doesn't matter because that will not be doing any work. And we split the force this time, so they're pulling with a force of 100 newtons, but some of that force is so-called lost because obviously, like I said, pulling vertical doesn't matter. So we solve for the horizontal force, and then we multiply that 15 meters because remember, work equals force distance. And approximating this, you should get 964.18 joules according to the answer sheet. Or if you like me, who loves to be as precise as possible, the answer is 964.1814145 joules. The next problem is really easy. Let me explain. Okay, it says, you and a friend are carrying a longboard. You move it a distance of 7 meters from the truck to the garage. If you are holding the board as pictured, how much work is done moving the board from the truck to the garage? So you and your friend are carrying it. You're simply just holding it. You're not lifting it or anything. You're just walking along with it. And the reason why it's 0 joules is because you're moving in a horizontal direction. And yes, this the longboard does move vertically, but you're not putting any force into the board. You're not like pulling it or pushing it like number 2. Like you're not pulling, just simply carrying it, which means they're not doing any work. And if you remember what we learned in class, if I was holding up a cup of coffee and I was walking all over the school and all over the classroom, like, yes, my arms probably would feel sore over a very long time, but I'm not putting in work. It's not moving vertically. And this is basically the same. That's just another example of this, of the same exact problem, which is why you are not doing any work, even though it seems like you are, because you're holding something. And number 4 is a 575 Newton box is lifted a distance of 20 meters straight up by a rope. The job is completed in 10 seconds. How much power is created? Show your answer in watts and kilowatts. Now, this is not just about work, it's about power. And power is measured in watts or in joules per second. And so it's work divided by time. So work is force distance, and that's time. So force times distance, all of that, and then you divide by time, which is 10 seconds. You figure that all out, you should be getting 1,150 watts or 1.15 kilowatts since it's asking us for both watts and kilowatts. And the next problem is a rock climber wears a 7.5 kilogram backpack while scaling a cliff. After 30 minutes, the climb is 8.2 meters above the starting point. How much work does the climber do on the backpack? If the climber weighs 645 newtons, how much work does she do lifting herself and the backpack? How much power was involved during the climb? And now let's tackle the first part. It's asking how much work does the climber do on the backpack? And first off, we remember that work equals force distance. And so 7.5 kilograms times 9.8 meters per second squared, this is our force. And then we multiply that by 8.2 meters to get an answer of 602.7 joules. And the reason why it's that answer because you're carrying something. So if you carry something, you carry it vertically. Like if you're holding something or lifting something up, it's a vertical force. And so in essence, force equals mass times acceleration. So that's our mass, that's our acceleration, and that's our distance, which is 8.2 meters above as given. And multiply all of them up, and you get 602.7 joules. And if the climber weighs 645 newtons, how much work does she do lifting herself and the backpack? You have to consider the force of the backpack, which we calculate to be 73.5 newtons, plus the climber herself, which is 645 newtons. You add them up first, then you multiply by 8.2 meters, because that's your total net force, the climber and the backpack. And you also have to consider the distance, obviously, which is still 8.2 meters. You add these first, multiply them to get 5,891.7 joules. And finally, it is asking how much power was involved during the climb. Since we know that power is work divided by time, it says 30 minutes, but we can't just divide by 30 because obviously time is measured in seconds. So you do 30 times 60, 30 minutes, and 1 minute is 60 seconds, which is 1,800 seconds. Or if you already remember it just like me, great. So we take the amount of work we got, and we divide that by the amount of time, which is 1,800 seconds, and we get our answer to be exactly 3.27316. The 6 here is repeating because I have a line over it. And that is our answer. Or if you want to approximate it, you can. It's 3.27 watts. And number 6. We also would discuss this in class. There's 2 ways to solve it, but the most obvious and easy way is simply to multiply these two to get our answer. And it says Walt wants to push a 500 Newton barrel up a ramp. How much work will Walt do if the ramp is 10 meters long, 5 meters high, and set at a 30-degree angle? How much work does Walt do if he simply lifts the barrel to the top of the ramp from the floor? So if he's lifting something, it's a vertical force. The work is vertical. And that means that horizontal doesn't matter. So like in essence, we only care about the vertical distance, which is 5 meters high. So we can ignore all of the other stuff and only look at this. So remember that work is force distance. So the force is 500 newtons, which we are given, times the distance, which is 5 meters. So 500 times 5 meters equals 2,500 joules. That's the fastest way to solve it. And we are moving on to homework number 2. All right. Number 1 states that two forces, F1 and F2, are acting on the box shown in the drawing, causing the box to move across the floor. The two force vectors are drawn to scale. Which force does more work? Justify your answer. Now you have to be really careful about this one, because if you look at the force, when you split the force of force 2, it looks like it's the same as F1, but F1's actually a little bit more force, so you do have to pay a little bit more close attention to that, since the forces are actually quite negligible, but F1 does a little bit more force, which means that since force 1 is doing more force, that means that force 1 is doing more work than force 2, because force 2 is just splitting up the force, which I'm sure you know how to do. Number 2, during a tug of war, Team A pulls on Team B by applying a force of 1,100 newtons to the rope between them. How much work does Team A do if they pull Team B towards them a distance of 2 meters? Again, this is just a simple work problem. Distance times force. Obviously, since there's no angle, it's just force distance. Multiply the two numbers, and you get 2,200 joules. And a tow rope oriented parallel to the water pulls a water skier for a distance of 86 meters. The work done by the tension rope in the rope is 1.9 times 10 to the 4th joules. Find the magnitude of the tension. This is pretty easy. It's our work which is given, which is actually a bit in reverse. So how force distance equals work. And in this case, it's just work divided by distance equals our force. And we're trying to get that force. So we do this, divided by that, plug it in. The answer is 220.93023226 newtons, or about 221 newtons if you want to go off the answer sheet. And that's it for number 3. A person pulls a toboggan for a distance of 35 meters along the snow with the rope directed 25 degrees above the snow. The tension in the rope is 94 newtons. Part A asks, how much work is done on the toboggan by the tension force? How much work is done if the same tension is directed parallel to the snow? Okay, we have to be a bit more careful here since this is an angular problem. So it's not simply force distance, it's force distance cosine theta. And because it asks for how much work is done by the toboggan on the tension force is given to us at 94 newtons. But do keep in mind, it is not just 94 newtons. We have to split it up to 94 newtons times cosine 25. And then you should multiply it by 35 meters. And you should be getting 94 times cosine 25 times 35. So if you plug it into your calculator, you should be getting 2,981.752619 joules for part A. And how much work is done if it is parallel to the snow? In this case, we don't need to worry about cosine theta because it's asking if it's parallel to the snow. So it is very simple. It is simply 94 newtons times 35 meters, which you get to be 3,290 newtons. Sorry, 3,290 joules. And that's it for number 4. And number 5 says a person pushes a 16 kilogram shopping cart at a constant velocity for a distance of 22 meters. She pushes the direction 29 degrees below the horizontal. A 48 frictional force opposes the motion of the cart. And part A asks, what is the magnitude of the force? It's very simple. All you need to do is split the force. And the answer is 54.88099526 newtons, or 54.9 newtons, based off of the answer sheet. And part B is what's the work done by the pushing force. Because we already have our force here, it's just force times the distance, which should be 1056 joules. Again, this is a bit different though, because this is just 48 times 22, because you're not splitting the force, because it's asking for the pushing, frictional, and the gravitational force. And that's pretty much it. The pushing force, 48 times 22, that's 1056 joules, and the frictional force, which also says is a 48 Newton frictional force, is negative 1056 joules, and the gravitational force is 0 joules, obviously, because you're pushing something, you're not like pulling, you're not like lifting something or something like that. So if you're just pushing something, the gravitational force is obviously just going to be 0 joules. And number 6 says you're trying to lose weight by working out on a rowing machine. Each time you pull the rowing ball, which simulates the oars towards you, it moves a distance of 1.2 meters in a time of 1.5 seconds. The readout on the display indicates that the average power you are producing is 82 watts. What is the magnitude of the force that you exert on a handle? And 82, and looking for we're using a power equation, which is power equals work divided by time. And so we set this equation up, which we find to be 123 joules, and it's asking for the force. So it's the work divided by distance equals the force, which you get to be exactly 102.5 newtons. And that was our answer. And number 7, it says, in an action-adventure movie, the hero lifts the 91 kilogram villain straight upward through a distance of 1.2 meters in 0.451 seconds at a constant speed. What power does the hero produce while doing this? First off, you have to calculate the villain's weight, which is 91 kilograms times 9.8 meters per second squared. So that's the force. And we multiply that by the distance, which is the work. And then the work divided by the time is the power, which is what this problem is asking for. So you multiply them, divide all of them together, you should get 2,098.3529141 watts, or about 2,098 watts. And finally, the last problem says, a 300 kilogram piano is being lifted at a steady speed from ground level straight up to an apartment 10 meters above the ground. The crane that is doing the lifting produces a steady power of 400 watts. How much time does it take to lift the piano? So you have 400 watts equals 29,400 joules divided by the amount of time. And obviously we're trying to find time, and this is just the power equals work divided by time, which we already calculate the work to be 29,400 joules, because it's just mass times acceleration times the distance, which is force distance. And once we solve for that, we get a time of exactly 73.5 seconds. And that is it. Hopefully this video helped, and peace out.